Okay, so we're going to talk about the elimination method now. The way the elimination method works is that when we combine these two equations, one of the variables you want to drop out or eliminate so that you can just solve for one of the variables. And when you have two equations, so let's look at this. So if we have like 1 equals 1 and 3 equals 3, these are two true equations. When I add them together, I get another true equation, right? If I add 1 plus 3, I get 4. 1 plus 3, I get 4. So adding equations together also produces a true equation. So it's alright to do it mathematically. This x plus y is equal to 10, right? Whatever x and y are, they together are equal to 10, and x minus y, whatever they are, together, when I take the difference of them, it equals 10. So I have basically 10 equals 10 and 10 equals 10. So I can add them together and get 2 x's. And then y minus y makes 0. So 0 y's. And 20, right? And 0 times any number is just 0. So that's how I got rid of the y, right? It eliminated. So I get 2x is equal to 20. So then I can divide both sides by 2 and get x equals 10. Okay, so then I can substitute that back into either equation and find out what y is. So 10 plus something equals 10. I think my y value has to be 0, right? So 10 minus, so then I could check my answer by plugging it into the second one. 10 minus 0, is it equal to 10? Yeah, that's a good check, is that if you check it, it makes it true for both equations. Okay, so now what would I do to make these equations or make one of the variables eliminate? It looks like I could still just add them straight up and get 0 for y, right? So I get 3x equals 9, so x equals 3. Or if I substitute back in, 3 plus something is equal to 4, so y better be 1. That's my guess. And then I could substitute it into the other equation to make sure for my check. So 2 times 3 minus 1 is equal to 5. Yeah, 6 minus 1 is equal to 5, so that checks out. Okay, so this is my ordered pair, my solution. And if I were to graph these, I would find that the intersection point between these two lines would happen at the point 3, comma 1. So sometimes you see the solution written like this. Okay, now I can't just add these two together and get an elimination, so I'm going to have to modify the equation in some way. And it is okay to multiply the equation by a whole number, or by any number actually, not just whole numbers. But if I had this situation, again, if I multiplied both sides of this equation by 2, right, and I got 6 equals 6, that's still true, right? And then I added them together, I would get something that is still true, right? 7 equals 7 if I add that equation to that equation, right? So what I'm going to do is I'm going to multiply one of these equations by a number so that one of the variables will eliminate. So how about if I stack 6 and negative 6, right, then it would be 0. So how do I make that a negative 6? Well, I just need to multiply this whole equation by negative 3. Okay, so negative 3 times 2 is negative 6. X, and negative 3 times 4 is negative 12. Y, and negative 3 times 7 is negative 21. Now I'm going to add this first equation to it. Okay, so 0x's, negative 15y's, and what's 21 minus 4? That's 17. Okay, I just made this up, so it's going to come up with an ugly answer, but that's okay. This is still a real answer, right? Divide both sides by negative 15, and I get y. So you get y equals 17 fifteenths, and this is negative 17 divided by negative 15, so it's positive 17 fifteenths. You could plug that back into either equation and find out what x is, but I'm sure the arithmetic gets pretty messy at this point, so I won't take the time to do it, but that's how you find a solution using elimination.